Hey students, this is Mrs. Tran-Bloom. 3.4 sets graphing absolute value functions. So here is the parent function. It's y equals absolute value of x. We will graph this in the HK form, which is f of x or y equals a, which is the number in the front of the absolute value form. It's always going to be a minus h and a plus k. Now obviously if h is going to be a negative, then inside would be an x minus a negative, so that would be a positive inside. Now if k is negative, then the n would be a minus. So it's not always a plus sign in the back, and it's not always a minus sign in the middle. So the first step we are going to try to do is graphing the parent function. You do need to know the terminology of a parent function because you will be asked to later on one of your exams what is the parent function for this. So make sure you know absolute value. The parent function is always, always, always just like that. We are going to pick some values to make our t-chart. We are always going to pick -2, -1, 0, 1, and 2. No, you don't have to pick those, but these are the easiest 5 values that I want you to use. Absolute value of a -2 is going to be 2. Absolute value of -1 is 1. Remember, absolute value makes everything positive, so that's why the output, aka the y value, it's always just going to be positive. Absolute value of 1 is 1. Absolute value of 2 is 2. So let's plot those. -2 is going to go up 2. -1 is 1. 0 is 0. 1 is 1. And 2 is 2. And technically we can keep on going. Use your straight edge and connect the dots. Okay, so now, as you can see, it looks like a V. The vertex of this is going to be the lowest point, which is at the origin, aka 0, 0. We do have an axis of symmetry. Remember, an axis of symmetry is, hey, is there a line that we can divide this thing into 2 equal parts? And that's definitely a yes. And that x is good, making it a little bit thinner. Okay, so that axis of symmetry is x equals to 0 for the parent function. For the x-intercept for the parent function is going to be 0, 0, which is the same point as the vertex, which is the same point as the y-intercept. Your domain is going to be all reals, or we can even write it in interval notation from -infinity to infinity. I want you to write it in both ways so that way you can get used to it. The range value, students, remember, look at the arrow, it goes upwards. That means everything is going to go towards positive infinity. Okay, upward means positive infinity. Now there's nothing down here, so we can't say all reals, but we do have a small value of y equals to 0. So the range is going to be inclusive, 0 to positive infinity, or back in the days, we write y is bigger than or equal to 0. Decreasing interval, remember we talked about decreasing interval is, can we slide down? Yes, this one is the sliding down piece. So decreasing interval is all the way here. And just to remind you, increase and decreasing interval, we are going to write using x only, okay? Small x. Well, remember, the smallest x that we can have is when this goes left forever. If it goes left forever, so the smallest x is going to be -infinity, and it stops right here at this point of x, and that point of x is going to be 0. So that's going to be decreasing function from -infinity to 0. Increasing interval, students, it's on the other side. Okay, increasing is when we can hike up. So if we hike up, we can, let's see. Woo, so tiring. Oh, I need some water, right? So that's when we can hike up. So that's increasing interval. And again, we're going to start with small x, comma, larger x. And the small x is going to be 0. Larger x, since this is go up and out, so that's going to be positive infinity. Rate of change, because all absolute value, students, are going to make up of 2 lines. We do have a rate of change. A rate of change is a slope, so we can just simply count up 1, right 1, up 1, right 1. So that's a positive 1. We can do up 1, left 1. So that's negative, right? Left is a negative. So we can say this is a positive or negative 1. Now also think about this. What is the A value in the front? If you don't see a number here, so that's really 1 times absolute value of x. So if this is the A value, then that's always going to be a plus or minus A value. It is not a 1-to-1 because it does not pass a horizontal line test. Can you see that? If we make 1 or 2 horizontal line tests, it is going to intersect more than 1 time. We do have a minimum value. The minimum value is always the y value of your vertex, if we have one, and that's going to be 0. We don't have a maximum value because remember the arrows here go up forever and ever, so that means we can't really pinpoint the highest, so this is going to be none. So what would you say the shape of an absolute value is? Now the shape, as we can see here, is definitely a V shape, right? A V shape. Would you agree with that? Yep. What is it made up of? It is made up of 2 rays. Okay, 2 rays. So that means rays are made up of part of a line. So that's why you're always going to have a plus or minus slope. Hence, rate of change is plus or minus for your V shape. Steps to graph absolute value functions. Now you can feel free to pause it and then copy this down. Step number 1, find the vertex, which is h comma k. Graph the vertex and the axis symmetry first so you can see that what's on the right side and what's on the left side, because axis symmetry is what divides it into 2 identical pieces. Determine if the graph opens up. Up is when your A value is positive. Down is when your value is negative. Then you want to get the slope and you want to go to the right. Then you want to get the slope and you want to go left. And then you're going to answer all of the characteristics, okay? Let's do example 2. Example 2, graph, then find all defining characteristics. So what we want to do is figure out what the h and k is. Now, the h and k form is always like this, x minus h, a times the absolute value of x minus h and plus k. So a is always in the front, so we do have an a value, students, okay? So a is going to be negative 3 over 4. This is a negative a, so we know it opens downward. Now the h value, remember, it is always going to be an x minus h. So what would we need to have this to be a positive 1? So x minus something. Well, that something has to be a negative 1. So your h value is negative 1. Now your k value, we don't have to switch the back. Whatever the back is, it's going to be your k. But the inside, always look at it. Inside, if it's positive, then you want to get a negative. If it's negative, then you want to get a positive. So your vertex, it's always h comma k, which is, in this case, negative 1 comma 5. And it says plot that. Negative 1 up 5. We know it opens down, okay? So your axis of symmetry, students, it's right here on the x location. So that means the right and the left will be exactly the same. So that's going to be x equals negative 1. Can you see that this right here is that value, except written as an equation form? The rate of change is whatever this front number is, except that we're going to have 2, a plus and minus, 3 over 4. So from the dot, students, that we just plotted, okay, then the vertex. We know there's one on the right and one on the left, but we need to have it graphed correctly using the slope. So we have 2 slopes. One would be a positive 3 over 4, and one would be a negative 3 over 4. Well, if it's on the right, and if it's on the left and the right, I'm just sketching out, don't do this. If it's on the left side, this is an increasing, so this is a positive slope, okay, so positive m. If it's on the left, well, I'm getting it backwards. I'm sorry, it's on the right, negative slope. If it's on the left side, it's a positive slope. So that's what we're going to use. We're going to use positive slope over here because it is opening downward. We're going to use negative slope on the right side. Okay, and then let's use it correctly. Let's count. From the point that we have, we're going to use a negative slope on the right side. That means I'm going to go down and right. 1, 2, 3. Negative 3 means down 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Do enough dots so that way you have a nice straight line. Okay, so that's the right side. The slope is a negative 3 over 4. Use it to sketch. Whee, just like that. And then the other side is going to be a positive 3/4. A positive 3/4 means I could go down and left. Okay, a negative down means a negative 3, left means a negative 4. So a negative divided by negative is a positive slope. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Enough dots so where you have this nice straight line both sides. Okay, so that is how we graph that. All right, next. X-intercept, do we have any? Yes, we do. We do have to solve for that, so I'm going to come back to that. Y-intercept, we do need to find that, so make sure we solve for that in a little bit. The domain is going to be all reals, okay? I want you to also know how to write it using interval notation, which is from negative infinity to infinity. The range is going to be all y values less than 5, okay? So y value less than or equal to, my bad. Or interval notation is going to be from negative infinity to positive 5 using a bracket. We do have an increasing. Increasing is going to be a positive slope, so that's going to be on the right side. And increase and decreasing notation, we're going to use negative infinity, which is the x value on the left, and then it stops at the h value, which happened to be a negative 1 for here. So it's going to be comma negative 1. Decreasing, it's over here, sliding down. Remember this? Whee! And so that's going to be from negative 1, comma positive infinity. We have a maximum value, so minimum value is none. Maximum value is the k value, which happens to be 5. Now, we do have to solve for the x and y-intercept manually. So, x-intercept, students, is when y equals to 0. Yes, we already studied this. So, x, ooh, why is that pen so fat? Okay. X int, y equals to 0. So 0 equals negative 3 over 4, absolute value of x plus 1, and then add 5. Now we're going to solve it by moving the 5. So that means now it's negative 5 equals negative 3 over 4, absolute value of x plus 1. We want to get rid of the negative 3/4. So we are going to multiply by negative 4 over 3. What's happening is that we're going to reduce this out to 1 in the front. Okay, all of that's going to cancel. What we multiply to the right side, we have to also multiply it to the left. So negative 4 over 3 as well. Now the negative 5 becomes a negative 5 over 1. So on the numerator, you're going to multiply horizontally. So a negative times a negative is now going to be a positive 20 over 3 equals absolute value of x plus 1. Remember we talked about solving for absolute value. The first equation is exactly the way it looks. And the second equation is when you switch the sign. Nothing has changed from the last unit. Okay. We will subtract 1 from both sides. A 1, that means the common denominator is going to be a 3. So multiply this by 3. So this becomes 20 over 3, taken away 3 over 3, which is 17 over 3. That's one x-intercept, which we will have to write that in. Minus 1, again, minus 1 is the 3 over 3, so that's going to give us another x value of a negative 23 over 3. So 2 x-intercepts. All right, let's fill that in. We are going to have positive 17 over 3 and a negative 23. Okay, so x-intercept will be positive 17 over 3, comma 0, and negative 23 over 3, comma 0. Both are x-intercept. Y-intercept, it looks like it could be a negative 4, but I'm not so sure. So I do want to make sure I plug it in, okay? So y-intercept, let's put x in for 0. So y-int, I just need some space. So y int students, x equals to 0. So y equals negative 3 over 4. The equation was x plus 1, so 0 plus 1. And then there's an addition of 5 in the back, plus 5. So y equals negative 3 over 4. 0 plus 1 is 1. Absolute value of 1 is still 1. So that's going to be plus 5. Negative 3/4 plus 5 student, that's going to be 4 1/4. So I'm glad I didn't guess that was going to be 4. It's 4 1/4. So write it in. 0, 4 1/4. Let's erase this. Right. Oh no, I didn't mean to erase my line. Put that back. All right, guys. F of x equals 2 times absolute value of x minus 3, and then take away 9. So what I want you to do is list out a is 2, h is going to be 3, and then k is going to be 9. Vertex is always h comma k, and so that means we should have 3 comma negative 9. Axis of symmetry, students, is always the x value of your vertex, aka the h value. So this one is really x equals to 3. We can plot that right away, okay? So 3 is going to be negative 9, which is all the way here. Immediately graph the axis of symmetry. So we know that it's going to divide it equally on the right and the left. The rate of change is always the plus or minus the a value, which happens to be 2. So that's going to be plus or minus 2. Now a is positive, so we know it will opens upward, okay? Opens up. Okay. So if it opens up, that means it's going to look like this. So the positive slope, student, is going to be on the right side, okay? So that means I'm going to m equals positive 2 over 1. That means on the left side, we'll have a negative slope, which is negative 2 over 1. So I'm going to use the point that of the vertex. I'm just going to start counting. Up 2, 1, 2, to the right 1. Up 2, 1 over 1, up 2 over 1, up 2 over 1. Enough dots to fill that side. So connect that. Okay. Now on the left, I can go up 2 students, but left, and that will give me a negative slope. Now we know it has to open upward, so you can't really go any other way. And the reason is that if you go down 2 and then left, then you're getting a line, and we know an absolute value has to make a V, so it does not make sense to go downward. Okay, so you're gonna go up and left, up and left, up and left, just enough to get a straight line. Just like that. So that's a V. X and y intercept, let's solve for that right now. X intercept is we are going to set y equals to 0. Yes, this is a skill that we do know. So 0 equals 2 times absolute value of x minus 3. Just like previous, we are going to try to isolate the absolute value. Add 9 to both sides. So that's going to be 9 equals 2 times absolute value of x minus 3. Then next, we want to divide both sides by 2. So 9 divided by 2 is 9 over 2 equals absolute value of x minus 3. This is when we are going to set this absolute value equal to 2 equations. The first is exactly the way it looks, okay? Then the second equation, students, is when we do the negative 9 over 2, and then we're going to solve for it regularly. Okay, so 9 over 2, students, that's like 4.5. So that's another way to think of it. So 4.5 or 4.5. And then if we were to add 3 to both sides, so 4.5 plus 3, so our first x-intercept is going to be 7.5. Okay. Similarly to this bottom one, negative 9 over 4, students, that's going to be negative 9 over 2 is like negative 4.5. And if we are going to add 3 to both sides to isolate the x, then that's going to be a negative 1.5 equals x. So that's going to be your 2x intercept, okay? Let's write it correctly. We are going to So the first x-intercept is 7.5, comma 0. Second x-intercept is negative 1.5, comma 0. All right, y-intercept. Ooh, yeah, that's a nice point. Look, I don't even have to do it in math. It's a nice perfect dot. So that's going to be 0, comma 3. Not 3, I'm sorry, negative 3. Okay. The domain is all reals. It's always all reals for a V shape or from negative infinity to infinity. The range looks like the lowest y value is going to be at negative 9. So from negative 9, and the arrows are going upward, so that's going to be positive infinity. Increasing interval is when the slope is positive, or remember we talked about we could hike up, okay? So on the right side of positive 3, that's going to be increasing because that half of the V shape is positive with a positive slope. So that's increasing. Now on the left side of the axis of symmetry, it's when the slope is negative. So that means it's decreasing. And that's decreasing from negative infinity to the h value, which is 3. This is not a one-to-one since it does not pass the horizontal line test. We do have a minimum value. A minimum value, student, is the y value, which is the k value, which is in this case is negative 9. And we have no maximum value.